Welcome to the DIY Honda Garage channel. DTC P0365 refers to a diagnostic trouble code that indicates a problem with the Camshaft Position CMP sensor circuit, specifically a no-signal condition. This code suggests that the sensor is unable to communicate its data effectively, which can lead to various engine performance issues. The CMP sensor is critical for the engine control module, ECM, to accurately determine the position of the camshaft, which in turn influences the timing of fuel injection and ignition. If the ECM cannot read this signal, it may adversely impact engine operations, potentially resulting in poor performance or even a failure to start. The camshaft position sensor is usually located in close proximity to the camshaft itself, often found on the cylinder head, at the rear or front of the engine, depending on the configuration. Understanding this code will aid in diagnosing and resolving issues related to engine timing and performance. The camshaft position sensor, abbreviated as CMP sensor, plays a crucial role in engine management systems. It provides vital information regarding the position of the camshaft, which is instrumental in determining when to inject fuel and fire the spark plugs. This sensor is typically mounted on the engine's cylinder head, securely positioned to track the rotor within the camshaft assembly. When functioning correctly, the CMP sensor sends a signal to the engine control module, ECM, helping to synchronize engine functions for optimal performance. A malfunction or absence of this signal, as indicated by DTC P0365, disrupts the entire engine operation process. Consequently, this could lead to unstable engine performance, increased emissions, or even a potential failure to start, making the CMP sensor a vital component to monitor. The causes of DTC P0365 can vary, but they generally point to issues within the sensor circuit. One potential cause is an open circuit in the wiring connecting the CMP sensor to the powertrain control module, PCM. This disruption can prevent the ECM from receiving essential signals about the camshaft positioning. Additionally, a defective CMP sensor itself could be the issue. If the sensor is damaged or malfunctioning, it will fail to send the correct data to the ECM, leading to this trouble code. Another possibility is a failed PCM, which could misinterpret signals or fail to register them altogether, exacerbating engine performance problems. Thorough diagnostics will help in pinpointing the specific cause of the DTC. When DTC P0365 is present, various symptoms may surface, indicating that the engine's performance is being adversely affected. One common symptom is noticeable engine performance issues, such as rough idling, stalling, or hesitation during acceleration, which can greatly impact the driving experience. Another potential symptom is difficulty starting the engine. The vehicle may crank without starting due to timing and fuel injection discrepancies caused by the faulty sensor. Additionally, drivers may experience reduced fuel efficiency as the ECM struggles to optimize engine parameters without accurate input from the CMP sensor. These symptoms serve as crucial indicators of the need for immediate diagnostic work to resolve the issues tied to the CMP sensor circuit. To begin troubleshooting DTC P0365, the first step is to turn the ignition switch to the on position, denoted as on 2. This action allows for the vehicle's electrical systems to engage without starting the engine. Following this, it's crucial to clear the Diagnostic Trouble Code, DTC, using the Honda Diagnostic System, HDS, an advanced tool utilized for diagnosing Honda vehicle systems. Once the DTC has been cleared, you should start the engine to determine if the fault reoccurs. This initial step is significant as it allows you to ascertain whether the error is active or has resolved itself, laying the groundwork for further diagnostics. It's essential to have an accurate starting point to identify persistent issues effectively. After starting the engine, The next necessary action is to check for any pending or confirmed DTCs with the Honda Diagnostic System, HDS. This reflects an essential procedure in the troubleshooting process, as it indicates whether the DTC P0365 is currently indicated or not. If the diagnostic check reveals that DTC P0365 is active, it guides you to the next troubleshooting steps. However, if it is absent, it suggests that the issue may be intermittent, indicating that the system may be currently functional and possibly affected by poor connections or loose terminals at the CMP sensor or the PCM. Identifying the current status of the DTC facilitates a clearer path toward resolution. For the subsequent step, turn the ignition switch to the lock position, ensuring that all systems are powered down before proceeding. Once this status is confirmed, disconnect the CMP sensor 3P connector carefully, ensuring not to damage the connector or wiring in the process. Following the disconnection of the sensor, you will turn the ignition switch back to the on position to power the vehicle's systems, while remaining cautious not to engage the starter. This disconnection and power up will allow you to test the sensor circuit effectively while assessing the voltage levels necessary for proper sensor function. This step is critical in isolating the sensor itself as a variable in the DTC diagnosis. Once the CMP sensor connector is disconnected, the next step involves measuring the voltage between CMP sensor 3P connector terminal number 1 and body ground. This is a diagnostic action that allows you to verify whether the necessary battery voltage is present at this terminal, which is crucial for the functionality of the CMP sensor circuit. Terminal number 1 should present a valid voltage reading. If this measurement indicates battery voltage, it confirms that the circuit has a positive connection between the CMP sensor and the main power source. If the voltage is absent, investigate further to locate any open circuits within the wiring leading to the PGM-FI main relay 1, as repairs will need to be made to restore proper connectivity before proceeding. After confirming the presence of voltage at terminal number 1, the troubleshooting continues with measuring the voltage between CMP sensor 3P connector terminal number 3 and body ground. Terminal number 3, which typically relates to CMP sensor data output, is essential for the correct transmission of positioning information to the engine control module, ECM. By evaluating voltage at this terminal, you can confirm if there is a signal output from the CMP sensor. If the voltage is detected, it indicates that the sensor may be working correctly. Yet further investigation may be required to verify if the signal is reaching the ECM. Conversely, if no voltage is present, this indicates a significant fault in the CMP sensor itself or the wiring leading from it, necessitating immediate repair actions. After completing the troubleshooting process and implementing necessary repairs for DTC P0365, it is essential to conduct a final verification to ensure everything is functioning correctly. Begin by confirming that all repairs were effective and that the CMP sensor wiring and connections were restored to optimal condition. Next, use the Honda Diagnostic System, HDS, to check for any new DTCs that might indicate ongoing issues. This is a critical step to ensure the ECM is receiving accurate signals from the CMP sensor. Finally, performing a road test is indispensable. This practical evaluation will help to validate that the engine operates smoothly under various driving conditions. A successful road test with no recurring issues would indicate that the repair process was comprehensive and effective. Preventive maintenance plays a vital role in avoiding the recurrence of issues like DTC P0365. Regularly inspecting electrical connectors related to the CMP sensor and the PCM can help identify any signs of wear or damage before they lead to significant problems. Additionally, conducting periodic wiring checks allows for early detection of frays, corrosion, or other types of damage that could disrupt signal transmission. Using high-quality parts when replacing components, such as sensors or wiring, can also contribute to the longevity and reliability of the vehicle systems. By adhering to these maintenance strategies, vehicle operators can ensure that their Honda Odyssey remains in optimal working condition and minimize the risk of encountering similar DTC codes in the future. In conclusion, DTC P0365 directly relates to the camshaft position sensor circuit, indicating a loss of signal that can severely affect engine performance. This code signifies that immediate attention is necessary, as any disruption in the operation of the CMP sensor can lead to poor engine timing and efficiency issues. The comprehensive troubleshooting process outlined helps in effectively diagnosing and resolving such issues by identifying whether the sensor, the wiring, or the engine control module is at fault. Conducting thorough checks, including voltage measurements at specified terminals, is crucial in determining the root cause of the problem. Lastly, preventive maintenance can help avoid future occurrences of DTC codes, ensuring that the Honda Odyssey remains a dependable mode of transportation. Please like and subscribe to the channel. See you next time!